In this video, we're going to talk a little bit about Mac stack buffer overflows. So I have a very simple program here. I include my standard headers. I have a main function that takes command line parameters, and I define a buffer. And the buffer, called buff, has a length of 20 bytes, which allows me to store 19 characters plus the terminating null. I then call stir copy, and I copy into this buffer foolishly my user supplied command line parameter, and then I return 0. So as long as the user doesn't give me anything longer than 19 bytes, I should be fine. So let's see what happens if I run this program. So here I have a terminal program. I'll go ahead and compile my program using the same utilities. I've actually pre-compiled this one. And as with Linux, I have to tell it, please don't use stack protection if I'm compiling using GCC, which is an option. So if I run my program stack with normal options, something that's not too long, it returns and nothing bad happens. Well, what if I give it more parameters? How much more? Well, I could type out my parameters by hand. That's certainly doable, but I might want to do something a little bit more sophisticated. And because Mac OS X is also based on Unix, Linux is based on one branch of Unix, and Mac OS X is based on the other branch. So they share a lot of similarities. There are some differences. Occasionally, they'll get you into trouble if you're going back and forth between these two systems. But one of the things that they share is the bash shell. So the bash is the default shell for Linux systems most of the time. And you can do things like instead of typing out a big string, I could do stack $, and then in parentheses, I can give it a command. I could say printf, etc. And that will use the printf command that's built into the shell. Or I could do something more sophisticated, such as this. I could say stack $, parenthesis, and now I could say Python, and I would like to give it a command, and the command that I will give it will be print, and I want to print a times 16. And then I will close that and give it a closing parenthesis. And now it runs and it gives me 16 A's. Wasn't enough to crash my program, which makes sense given that we said that we had 19 bytes to play with. What if I give it 20 bytes? Is that enough? Sometimes that's not enough. You have to go a little bit over because of alignment issues and things like that. So if I give it 24 bytes, I'm still good. What about 34 bytes? I'm still doing fine. And I'm going to go all the way to 44 bytes. Now I have a segmentation fault. So as you can see, any platform where you have a program with a stack buffer overflow could potentially be a problem, and the Mac is no different.